Hello guys, how are you doing today? I'm really missing you. I know each time I talk to you through my videos I say I really miss you, but it's really true. I hope to see you soon. Okay, so I hope you had great family resting days and you are super ready, and let's buckle up and put all of our effort to finish this last part of the year that it's almost over. Okay, so we're grading May now, so let's put all of our effort, guys. Okay, so right now you already watched a video about specific heat with another teacher that I found, but I want you to tell you this information in other words, okay, with my explanation to have it covered all of the doubts. And if you still have doubts, remember you can reach me. Okay, so let's continue learning on what is specific heat. If I go to this image, we have different substances, okay? Mercury, sulfur, sodium chloride, for example. These different substances, and all of them in the periodic table, absorb heat at different rates due to their structure or characteristics. Let me explain you in other words. Okay, let's say we have these Bunsen burners, and I decide to heat up the sulfur and the sodium chloride, okay? And the specific heat will be that the sodium and the sulfur need different amount of heat to increase their temperature on 1 degree Celsius, okay? So let's say if we want to increase this one from 30 degrees to 31 degrees, and this one as well, they would need different amounts of heat. So let's go back to the specific heat, to the meaning, okay? Which will be the amount of energy required to raise the temperature of 1 kilogram of a material by 1 Kelvin. Okay, but in the problems we'll be working on, guys, Kelvin is not that in our daily lives. So the meaning we will be using, guys, is this one. The amount of energy needed to heat 1 gram of water or any other substance by 1 degree Celsius, okay? Which means that is the amount of energy required to raise 1 degree Celsius, okay? In this case, it would be from here to here, 1 degree Celsius, 1 gram of any substance, you name it, okay? It can be, I don't know, mercury or whatever, but each 1 gram has its own specific heat, okay? Imagine it's like a fingerprint. Okay, and as each substance has its own fingerprint or specific heat, water has its own specific heat. The specific heat of water will be 4.184 joules over grams per degree Celsius. It means that, imagine this one is water, and I have the Bunsen burner here, and you need 4.184 joules to increase this gram of water, let's say from 20 degrees Celsius to 21 degrees Celsius, okay? And you would need to double this one to raise it to 22 degrees Celsius, and so on and so on. If you would start to do this experiment at the laboratory, first you need to understand the formula, okay? The formula of heat will be, it would be heat equals mass times specific heat times delta of temperatures. What, teacher? What is that? Okay, let's start. Q will be for heat, and heat will be given in joules, okay? You also can change joules to calories or kilocalories, okay? And then we have M, which is the mass, and the mass will be given in grams in this case. And then you have specific heat, in Spanish is calor específico, which is joules over gram per degree Celsius, but scientists, it's important for you to know that it's joules over kilogram per degree per Kelvin. And then we have delta temperature. Okay, this is a triangle. Delta, guys, delta means difference. Or subtraction. Okay, so regularly you will have, it doesn't matter, you need to choose which one to put first, the higher temperature or the lower temperature, okay, to have a positive answer, and I'll show you right now. But how you will express the delta will be heat equals mass times specific heat times temperature 2 minus temperature 1. Let's say that example. Okay? Now, to learn about heat transfer, you use a process called calorimetry with a calorimeter. A simple example of a calorimeter will be with a coffee cup. Look how this experiment works. A coffee cup is a pretty good insulator. That is why we use it for coffee, so that the heat doesn't escape so quickly and the coffee stays hot for longer. This makes it possible to take reasonable data about the change in temperature in a cup of water. When we add a hot piece of metal, for example, we can measure the change in the temperature of the water and calculate the specific heat of the metal. So let's say you heat up a metal by placing it in a boiling water of 100 degrees Celsius until it is just as hot as the water. Then you place it in a coffee cup containing a known volume of 20 milliliters of water at room temperature of 25 degrees Celsius. The water in the cup will heat up slightly as the heat from the metal flows into the water, and we can record the resulting change in temperature, writing down the final temperature, and then you just do the math. So according to this information, we know that we're searching for heat. Heat equals question mark. We also will have a mass. The mass, you need to know that for water at room temperature, 1 gram is the same as 1 milliliter. So, in this case, is 20 grams. Then you also have temperature 1 and temperature 2. In this case, is the one of water. So the initial temperature of the water was 25 degrees Celsius and the final temperature of the water is 33.8 degrees Celsius. So we have here 33.8 degrees Celsius. And the specific heat that I will always give it to you, because it's like gravity, it never changes, of water, is its fingerprint, so 4.184 joules over grams per degree Celsius. And with this information, we put our formula. Heat equals mass times specific heat times delta of temperatures, which is mass times specific heat times, let's remember that in this part right here, I don't want negative numbers. So I'll put temperature 2 minus temperature 1 to get a positive number. So temperature 2 minus temperature 1. So we had heat equals 20 grams times 4.184 joules over grams per degree Celsius times 8.8 degrees Celsius. So then we have heat equals, you multiply everything, and it will give you heat, which is 737 joules. How do I get that? Well, I cancel grams that is at the top here, grams that is at the bottom here, then degrees Celsius that is at the top, and degrees Celsius, no, this one is at the bottom, sorry, and this one is at the top, and that's how you keep the joules. Okay, now this heat is the heat absorbed by the water. And you already know that energy can't be created or destroyed. It's only transferred. So the way that the water receives 737 joules, the metal releases 737 joules. Metal releases. So it's important to know that the heat absorbed by the water is the same heat that is released by the metal. Okay, so with this information, we know the amount of heat released by the metal. We have our formula again. Heat equals mass times specific heat times delta of temperature. This other information, we did it with the information of the water. Now let's use the one of the metal. We already know that 737 joules were released. The mass, I forgot to tell you, but is of 9.25 grams. So we measured it before we started the experiment, let's say. And then you have a specific heat, which you don't know. The specific heat you don't know. And the delta of temperatures, but now this delta of temperatures is the one of the boiling water. The one of the boiling water is 100 degrees Celsius minus 33.8 degrees Celsius. Okay? So you have 737 joules equals 9.25 grams times specific heat times 66.2 degrees Celsius. What should you do? You'll multiply 9.25 times 66.2. So you'll put 737 joules equals 612.35 grams degrees Celsius times specific heat that we don't know. And the next step is to clear the formula. Bring it down dividing. So if we divide it, my specific heat of the metal will be 1.2 joules over grams per degree Celsius. And if you search in the web or in a book, what is a metal with 1.2 specific heat, you'll find it. Okay? So if you were wondering where could you use this experiment, would be actually measuring the calories that any type of food has by changing joules with your lovely box procedure to calories and kilocalories, because you already have the unit conversions, and heating it up would give you exactly the calories anything has. So thanks for watching, and please finish your worksheet and handling today. Thank you guys. Bye.